fractions. At this point, we get that a is going to be negative because negative divided by positive is negative, different signs, negative. And we get that b is going to be positive because negative divided by negative is positive, same sign, positive. So let's use this opportunity to review dividing fractions and how we do that. Keep, change, flip. Keep the first fraction the way it is, change division to multiplication, and then take the reciprocal, flip the second fraction. So negative 5/9 times 3/2 is what we would change this to. Negative times positive is negative. Multiply across the top, multiply across the bottom. 5 times 3 is 15. 9 times 2 is 18. Negative 15/18 then reduces to negative 5/6. Why? Because we can divide the top and bottom by 3. In part B, negative 2/7 divided by negative 1/5. Negative divided by negative is positive. But what we're interested in is the keep, change, flip. Keep 2/7 the way it is, change division to multiplication, and then flip 1/5. So it's 5/1. Negative times negative is positive. 2 times 5 is 10. 7 times 1 is 7. So positive 10/7. The third objective in this topic: simplify expressions containing exponents. Hello, everyone. Today we're going to start by talking about something called exponential notation. So let's say we had repeated multiplication like 2 times 2 times 2. We could write this as 2 to the third power, where 2 is what we call the base, and 3 is what we call the exponent. So an exponent is a little floating number off to the top right of a base. And the exponent tells us how many factors of the base there are. We had 2 times 2 times 2. 1, 2, 3 factors of 2. So 2, the factor that's repeated, is the base. 3, the number of factors we have, is the exponent. And we would evaluate this from left to right because it's all multiplication. 2 times 2 is 4 times 2 is 8. Let's evaluate some other things written in exponential notation. Feel free to pause and work along once you catch on to what we're doing. 3 squared, that's 2 factors of 3. And 3 times 3 is 9. So 3 to the second power is 9. When we have a second power, I might have already said it because it'll come natural to you eventually. The second power we referred to as squared. Squared means a number times itself. 5 to the third power That's 3 factors of 5 because 3 is the exponent. 5 times 5 is 25. 25 times 5 is 125. So 5 to the third power is 125. And when we have a third power, we refer to that as cubed. So we could say 5 cubed is 125, or in the example we started with, 2 cubed is 8. We don't have any special names for fourth power and on, so this would only be able to be read 2 to the fourth power, but that's 1, 2, 3, 4 factors of 2. Left to right, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So again, 2 times 2 is 4. 4 times 2 is 8. 8 times 2, 16. 2 to the fourth power is 16. Couple more. Fractions, very important. We're going to keep coming back to fractions. Fractions make up a large portion of this first part of the material because it's important that we're comfortable with them. We know how they work. We know how to add, subtract, multiply, divide them. First off, 7 to the first power. The exponent 1 tells us we just have a single factor of 7. So anything to the first power is itself. 7 to the first is 7. Now on to this fraction. 3/7 squared, 3/7 to the second power. That's 2 factors of 3/7. We have 3/7 times 3/7. Multiplying fractions, nothing cancels. Multiply across the top, 3 times 3 is 9. Multiply across the bottom, 7 times 7 is 49. 9/49. So as we've been evaluating, I said it's all multiplication. We can just go from left to right. I want to take a look at 2 things here. And they look very much the same, except over here, -2 to the third power, the -2 is in parentheses. And here, -2 to the third power, there are no parentheses. These mean 2 different things. Here, the base, the thing being cubed, is a negative, -2. It's in parentheses. That means we have -2 times -2 times -2. -2 times -2 is +4. +4 times -2 gives us -8. Here, this is the same as -1 times 2 to the third. The negative is not part of the base. The base is only 2 because there's no parentheses including the negative into the base. So this is -1 times 2 times 2 times 2. -1 times 8. Again, we get -8. But the reason we get the same answer is because we were cubing. We were taking an odd number of factors of the base. We're going to see next, if we had an even exponent and did this exact same thing, we would not get the same answer. So the parentheses or lack thereof is actually very important to making sure we get the correct answer. This time, let's take a look at -3 squared and -3 squared. One with parentheses around the -3, one without parentheses. -3 in parentheses means the -3 is the base. That's -3 times -3. Negative times negative is positive. We get +9. Here, the negative is not part of the base. The square only applies to the 3. This is the same as -1 times 3 squared. Or -1 times 3 times 3. -1 times 9. We get -9. Or if you go left to right, -1 times +3 is -3. -3 times +3 also gives us -9. We're going to see in the next video why we're able to multiply in any order and still get the same answer. It's one of the properties of multiplication. But for now, notice negative in parentheses. When we squared it, we ended up with a positive answer. And that was because we have an even number of factors. And remember, multiplying a negative an even number of times is going to work out positive. Here, the negative has nothing to do with the squaring at all. This might as well say the opposite of 3 squared, the opposite of 9, -9. It's the same as considering this minus a -1 times. But the negative has nothing to do with what we are squaring. Here the base is -3. Here the base is +3. Objective 4 in this topic is find roots of numbers. So what is a square root? Well, it's the opposite of squaring a number. Taking the square root is the opposite of squaring. A number b is a square root of a number a if b squared equals a. In order to find a square root of a, you need a number that, when squared, equals a. What does all this mean? Well, let's take a look at part A in the examples. Find each root, the square root of 16. Well, a number is a square root of 16 if there is a number times itself, or a number squared, that gives us 16. Is there such a number? Yes, it's 4, because 4 squared is 16. Now, if we go back, you might have noticed a number b is a square root of a number a if b squared equals a. So another square root of 16 could be -4. -4 times -4 is +16. However, when you see the symbol, when you see the square root symbol called a radical, that indicates only the positive. If they wanted the negative, there would be a negative in front of the symbol. So our only answer is +4 when it's written this way. Again, don't be scared off by the fraction. Imagine that the radical was on the top and on the bottom. What's the square root of 1? What times itself is 1? 1. What times itself is 36? 6. So 1/6. because the square of the fraction is the square of the top over the square of the bottom. Now C wants a cube root of 27. This would be a number times itself a total of 3 times equaling 27. That number is 3 because 3 times 3 is 9 times 3 is 27. 3 cubed is 27. And for D, we want the fourth root of 16. This is a number when it's multiplied by itself a total of 4 times gives us 16. That number is 2. Two times 2 is 4, times 2 is 8, times 2 is 16. The fifth objective in this topic is use the order of operations. But what if we have a mix of signs? Stepping away from exponential notation, just to this problem here, 2 plus 3 times 7. Well, it depends on what you do first, the answer you get. If we go from left to right, 2 plus 3 is 5. 5 times 7 is 35. I put that in red. That should be a red flag. What if we multiplied first? What if this was 2 plus 3 times 7? Well, if we multiply first, 3 times 7 is 21. 2 plus 21 is 23. I put that one in green. Which is the right answer, 35 or 23? And it turns out the answer is actually 23. Why does it turn out that the answer is 23? It's because of something called order of operations. Order of operations tells us that first we would work inside grouping symbols, parentheses, brackets, things like that. Then we would deal with exponents. Then we multiply and divide from left to right as we come to it, which will leave only addition and subtraction, and then we do the addition and subtraction from left to right as we come to it. Parentheses, grouping symbols, exponents, multiplication and division, addition and subtraction. PEMDAS. People usually remember PEMDAS as please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally will help you remember PEMDAS. Parentheses, exponents, multiplication and division, addition and subtraction. And notice I keep grouping multiplication and division together. I keep grouping addition and subtraction together. Order of operations is a 4-step process. Multiplication and division are in a step together from left to right as you come to it. Addition and subtraction are in a step together, left to right as you come to it. This does not mean do multiplication first, then division. This does not mean do addition first, then subtraction. Once again, the multiplication and division is left to right as you come to it. Division might come before multiplication if it's first. Addition and subtraction left to right as you come to it. Subtraction might come first. Let's do a bunch of problems now involving the order of operations. And actually, let me put PEMDAS up in the corner so we're always aware. I always write it like this, showing what the 4 steps are, showing that multiplication and division is left to right, addition and subtraction is left to right. Let's take a look at 6 divided by 3 plus 5 squared. Order of operations says first we work inside parentheses and grouping symbols. We don't have any of those, so we move on. Order of operations says next we do E, we do exponents. Everything else stays the same. 5 squared is 25. Next, we look for any multiplication and division that we have from left to right as we come to it. And this very first thing is a division problem. 6 divided by 3. That's 2. Leave the rest alone. Finally, we have 2 plus 25. Our answer is 27. Let's look at another. "20 divided by 5 times 4. Now, I feel like I'm beating a dead horse at this point. Multiplication and division, left to right, as you come to it. We're on that step already because there's no parentheses, there's no exponents. It's super important that that left to right, as you come to it, is how you do the problem. First, we have this division. 20 divided by 5 is 4. Leave the rest alone. Now we have 4 times 4. The correct answer is 16. If you didn't follow order of operations, or I should say, if you misunderstand the order of operations, if you look at PEMDAS and go, M comes before D, multiplication comes before division, you would do 5 times 4 first, which would give you 20. Then 20 divided by 20 would be 1. That is not correct. It does not give you the same answer. Order of operations is all about making sure you can consistently get the same answer as everybody else doing the problem. There should be no situation where you look at this and you get an answer of 1. Unless it's written like this. I put parentheses around the 5 plus 4, sorry, the 5 times 4. And now when I follow order of operations, parentheses first. Inside the parentheses, we have 5 times 4. 20 divided by 20 is 1. So written like this with parentheses around the 5 times 4, that's the only way that these numbers work and give you 1. So order of operations is important to follow, and understanding that multiplication and division is in 1 step left to right. Addition and subtraction is in 1 step left to right. It's not multiplication first. It's not addition first. That won't always be the case. Okay, let's do some more. 2 times in parentheses 12 plus 3 all over the absolute value of negative 15. When we have it looking like a fraction, when we have a division bar, we treat the top as one problem, we treat the bottom as one problem, and once they're both simplified as far as they can go, we divide at the end. Or if it's not divisible, we reduce the fraction form that we have. So what do we do on top? Parentheses first. Inside the parentheses, 2 plus 3 is 15. All that's left on top is 2 times 15. That's 30. On the bottom, we just have the absolute value of negative 15. Since that's all there is to do, there isn't any confusion about what comes first on the bottom. But if there were other things happening down there, absolute value is a grouping symbol. So it would fall under parentheses. We would work inside the absolute value in a first step. The absolute value of negative 15 is positive 15. Nothing else to do to that, so let's carry it over to here. They're both simplified top and bottom as far as they can go. So we divide 30 divided by 15 is 2. And again, had that not been able to divide evenly, we would just reduce the fraction. Next up, 3 times 4 squared. Be very careful. Parentheses, no grouping symbols, nothing to do there. Exponents. We have to do the exponent next. What is the base? The base is just what the exponent touches. So it's just a base of 4. Leave the rest alone. So we have 3 times 4 squared. That's 3 times 4 times 4. This is not 3 times 4 equals 12 and then 12 squared. Let's finish this off. It's all multiplication, so left to right as we come to it. 3 times 4 is 12. 12 times 4 is 48. If the problem intends us to do the 3 times 4 first, it would be in parentheses. So see the difference. In this first one, the exponent of 2 is only attached to the 4. So all we'd square is the 4. Here, the parentheses group the 3 times 4 together. We work in parentheses first. 3 times 4 is 12. So we have 12 squared, which means 12 times 12, which means 144. So 2 very different answers. The only thing that's changed in the problem is parentheses are in one, but not the other. Fractions are important. Three halves times 1/2 minus 1/2. Order of operations says Parentheses, we have none. Exponents, we have none. Okay, so now let's multiply and divide from left to right as we come to it. This first problem is multiplication. 3/2 times 1/2. That's 3/4. So we have 3/4 minus 1/2. 3 times 1 is 3. 2 times 2 is 4. Then we have 3/4 minus 1/2. In order to do that, we need a common denominator. That common denominator is going to be 4. One half written with a denominator of 4 is 2/4. 3/4 minus 2/4 gives us a final answer of 1/4. So order of operations, important. If instead of multiplying first, you mistakenly subtracted first, you would do 1/2 minus 1/2 is 0. Anything times 0 is 0. You would get an answer of 0, which would be wrong. Let's look at another crazy one. Three plus the absolute value of 4 minus 3 plus 2 squared all over 6 minus 3. We have a fraction bar. Top and bottom, 2 separate problems until the end. And on the bottom, all we have is 6 minus 3. Let's just go ahead and make that 3 now. On top, first comes parentheses, but remember parentheses means any grouping symbol. We have a grouping symbol. We have this absolute value. So we work inside the absolute value first. 3 plus the absolute value of 1 plus 2 squared. What is the absolute value of 1? It's just 1 plus 2 squared. No more grouping symbols. Exponents. We've got one. 2 squared is 2 times 2, that's 4. 3 plus, all that's up on the top is addition. So left to right as we come to it. 3 plus 1 is 4. All that's left on top now is 4 plus 4, which is 8. Can we do 8 divided by 3? No. So we leave it in fraction form. It does not reduce. You want to try one of these crazy ones? If you feel like a challenge, go ahead and pause this next one. I'm going to go ahead and get started with it. Top and bottom, 2 separate problems. On top, we have no parentheses. Exponent, 6 squared is 6 times 6, that's 36. 36 minus 5 is 31. So that's all we can do on top. Let's start working in the bottom. Parentheses, grouping symbols. We have the absolute value. 3 plus the absolute value of 6 minus 5. 6 minus 5 is 1. Times 8. The absolute value of 1 is 1. 3 plus 1 times 8. What comes first, the addition or the multiplication? PEMDAS says multiplication comes before addition. So leave the 3 plus alone. 1 times 8 is 8. And then 3 plus 8 is 11. 31 over 11 is our answer. Three bracket 4 plus 2 parenthesis 10 minus 1 close parenthesis close bracket. In this problem, we have two sets of grouping symbols. We've got these parentheses. We've got these brackets. Those aren't absolute value signs. These are brackets, square parentheses. Where do we start? Parentheses grouping symbols comes first. We're always going to start with the innermost set of grouping symbols first. Why? Let's say we start with the other ones first. We technically are. Why? Because inside this grouping symbol, what would we do first? Grouping symbol. So we always end up first at the innermost grouping symbol. Leave everything else alone. 3 square bracket, 4 plus 2 parentheses, bracket. Inside the parentheses, 10 minus 1 is what we do first. 10 minus 1 is 9. Now there's nothing else to do inside these parentheses. This now means 2 times 9. Whenever we have a number right up against parentheses, it means multiplication. Now, these are the only grouping symbols that are left, these brackets. Working inside the brackets, we have to take care of 4 plus 2 times 9. This is not 6 times 9. Order of operations says we do multiplication first. 4 plus 2 times 9 is 18. We have the 3 right up against this bracket. That, just like the 2 times 9, the parentheses meant times, the bracket means times. There's no difference between square parentheses and regular parentheses. They're just different shapes, so you don't get confused as to which starting one goes with which ending. So this is 3 times 4 plus 18 is 22. 3 times 22 is 66. Let's do one more like that. Feel free to try. Four, then in brackets, 25 minus 3, then in parentheses, 5 plus 3. Close the parentheses, close the bracket. Innermost grouping symbol first. 5 plus 3 is 8. Inside the brackets, multiplication first. 25 minus 24 is what we're left with, which we still do because we're working inside the parentheses, the grouping symbols. 25 minus 24 is 1. 4 times 1 is 4. Two more. Fraction bar means we have two problems. On the top, we would multiply first. Leave the 8 plus. 2 times 3 is 6. 8 plus 6 is 14. On the bottom, exponent first. 2 squared is 4. 4 minus 1 is 3. We can't reduce 14 thirds. 14 thirds is the answer. Feel free to try. I'm going to get started with it. On the bottom, 5 squared is 25, exponent first. 25 minus 3 is 22. On top, division first. 36 divided by 9 is 4. 4 plus 5 is 9. 9 over 22. Looking at this, be careful. This is not 4 things multiplied together. This is 2 things multiplied together, and then we are subtracting 2 more things multiplied together. So if we follow order of operations, we have to do the multiplications first. Negative times negative is positive. 4 times 11 is 44. Then we are subtracting 5 times negative 2. Positive times negative is negative. 5 times 2 is 10. So we have 44 minus negative 10. Just like we did last time, minus a negative turns into a plus. 44 plus 10. We get 54. So what if we have 0 times negative 8? All divided by 2. Well, 0 times anything is 0. So this is 0 over 2, which is allowed. That one's 0. But if we have this, -5 divided by 6 times 0, again, anything times 0 is 0. So this is 0 on the bottom. That's not allowed. So that one is undefined. Okay. Next, I'd like to talk about the placement of a negative in a fraction. So I've written 12 divided by 1 3 times. But there's a difference in that here it's positive 12 divided by -1. Here it's negative 12 divided by positive 1. And here it's the negative fraction 12 over 1. Well, positive divided by negative is negative. 12 divided by 1 is 12. Negative divided by positive is negative. 12 divided by 1 is 12. And here we have negative 12 divided by 1. 12 divided by 1 is 12. Each of these has the answer of -12, which means each of these are equal. So when we have one negative sign, it doesn't matter if it's on the bottom of the fraction, if it's on the top of the fraction, or if it's outside of the fraction. It all means the same thing. A negative fraction can either have the negative on the top or on the bottom, but not both, because if we gave it to both, it would be negative divided by negative, which would turn the whole thing positive. So a negative on the outside of a fraction cannot be given to both the top and the bottom. It's either the top or the bottom. In general, a over negative b equals negative a over b equals negative the entire a over b. Let's look at some more complicated looking things. So we need to follow order of operations. The top and the bottom should be treated as two separate problems. On top, we would multiply first. -12 times -3 is positive 36. On the bottom, minus a negative turns into plus. -36 plus 3 is 39. -7 plus 2 is -5. So either 39 over -5, or we can take that negative out to the front and get -39 fifths. Why? Because positive divided by negative is negative overall. Next step, we have 2 times negative 3 squared minus 20 on the top and negative 5 plus 4 on the bottom. The negative is inside parentheses. Order of operations says we have to take care of this exponent first. Negative 3 squared means negative 3 times negative 3, which is positive 9. On the bottom, negative 5 plus 4 is negative 1. On top, we multiply before we subtract. 2 times 9 is 18. Minus 20 over negative 1. 18 minus 20, or 18 plus negative 20, is negative 2 over negative 1. Negative divided by negative is positive. 2 divided by 1 is 2. So our answer here is positive 2. The sixth objective in this topic is evaluating algebraic expressions. Variables are letters that stand for numbers. Previously, we've used, when we were talking about fractions, A, B, C, D, but you'll also see N, X, Y, Z. Any letter can be a variable, and variables just represent numbers. When we have a collection of numbers, mathematical symbols, and variables, we have what's called an algebraic expression. So things like 2y or 3x plus 1 or 3 over x plus y over z. These are algebraic expressions. They're mixtures of, even just the number 6 is an algebraic expression. We have a mix of numbers, variables, and signs like plus or minus, times or divided. One thing we can do with expressions is, if we are given a value for the variable, we can plug that number into the expression and evaluate it. Evaluate for this next group when x equals 3 and y equals 2. Evaluate means we have some expression like 2x minus y, and we want to plug in 3 for x. We want to plug in 2 for y. What does this have to do with what we're talking about today? Well, once we plug the values in, we have to follow order of operations to continue to evaluate to an answer. Multiplication first, 2 times 3 is 6, minus 2, 6 minus 2 is 4. We just evaluated 2x minus y when x equals 3 and y equals 2 and got an answer of 4. Same values. Three x over 2y. Feel free to try these. We plug in 3 for x. We plug in 2 for y. 3 times 3 is 9. 2 times 2 is 4. We get 9/4. X over y plus y over 2. 3 is x. 2 is y. 2 is y. 3 halves plus 2 halves is 5 halves. X squared minus y squared. When we plug in values that are squared or cubed or to any power, use parentheses. Because whatever we're plugging in its entirety is the base. Here, x squared, the base is x. So the base is however much information we have for x, all of it. In this case, it's only 3. And for y, we only have 2. 3 squared is 9. 2 squared is 4. 9 minus 4 is 5. Keep this skill fresh. So if we establish that x equals 2 and y equals -5, let's evaluate x minus y over 12 plus x. So on top, x minus y, 2 minus -5. On the bottom, 12 plus x is 12 plus 2. Minus negative is plus. 2 plus 5. Over on the bottom, 12 plus 2 is 14. Is 7 over 14, which reduces to 1/2. Except for the fact that we're going to have negative numbers with multiplication and division instead of just addition and subtraction or positive numbers. Nothing is new here. Oops. Okay, x is -2, y is -4. We want to evaluate 5x minus y. Go ahead and give this a try. When you're done, hit play. I'm going to go ahead and do this now. This would be 5 times -2 for 5 times x, and then minus -4. Be careful. Minus y means minus -4. Be careful with your signs. 5 times -2 is -10. Minus a negative turns into plus 4. And then -10 plus 4 is -6. We're going to keep x equals -2 and y equals -4. We're going to change the expression. This time we're taking a look at x to the 4th minus y squared. The x that we're raising to the 4th power is -2 minus the y that we're squaring is -4. Off on the side, we'll take a look at -2 times -2 times -2 times -2. Negative times negative is positive, times negative is negative, times negative is positive. Even number of negatives works out to a positive answer. You can go -2 times -2 is 4. -2 times -2 is 4. +4 times +4 is +16. Again, next video, we'll see why we can multiply these in any sort of grouping. It's one of the multiplication properties. Or you can go left to right. You'll get the same answer. -2 times -2 is +4. +4 times -2 is -8. -8 times -2, +16. So however you come about it, -2 in parentheses to the 4th power is +16. How did we know there should be parentheses there? We give the parentheses to ourselves because it is the entire x raised to the 4th power, and that negative is a part of that entire x. So we can't just write -2 to the 4th without parentheses, because this would not indicate that the entire x is getting raised. There needs to be parentheses there. -4 squared, somewhere off on the side, we do -4 times -4 would give us +16 also. So this is 16 minus 16. 0 is our answer. How about the absolute value of x minus the absolute value of y? All over x minus y. The absolute value of x would be the absolute value of -2. The absolute value of y would be the absolute value of -4. All over x minus y, -2 minus -4. On top, taking absolute values, we get 2 minus 4. On the bottom, minus a negative turns into plus, so this is negative 2 plus 4. Two minus 4 is negative 2. Negative 2 plus 4, that's positive 2. Negative divided by positive is negative. 2 divided by 2 is 1. So we get an answer of negative 1. And how about a fourth one just for fun? This will be the last problem of the day. Three x over 2y. That's 3 times negative 2 over 2 times negative 4. 3 times negative 2 is negative 6. 2 times negative 4 is negative 8. Negative divided by negative is positive 6/8, which reduces to positive 3/4. Okay. For A and B, we're given x equals 9 and y equals negative 4. Let's look at A first. The expression we're given is just negative 3y squared. We are plugging negative 4 in for y. We are plugging the entire negative 4 in for y. So since the entire y was squared, the entire negative 4 is squared. That tells us that the negative 4 must be inside of parentheses. Exponent comes next. I should say exponent comes first, now that we can actually do something. Negative 4 squared with the negative inside the parentheses means negative 4 times negative 4. That's positive 16. Negative times positive is negative. 3 times 16 is 48. For B, let's plug in 9 for x and negative 4 for y. We can do a little bit of simplification. Radical 9, the square root of 9 is 3 because 3 times 3 is 9. We then have negative 3/4 minus 4/9. Let's do another simplification of subtracting fractions problem. We need a common denominator. That common denominator is going to be 36. We get to 36 by multiplying the 4 times 9 and the 9 times 4. So to get the equivalent fraction, the negative 3/4 is multiplied by 9 over 9. The minus 4/9 is multiplied by 4 over 4. That gives us negative 27 over 36 minus 16 over 36. Don't panic. I should have said that earlier. You might be panicking now. Stop it. Don't. It's fine. We know what we're doing. Common denominator is 36, so that's a 36 on the bottom. And then we have negative 27 minus 16. You're $27 in debt. You go in debt 16 more dollars. You're now in debt $43. Negative 27 minus 16, that's negative 27 plus negative 16. We're adding, the common sign is negative. 27 plus 16 is 43. So negative 43 over that common denominator of 36. And there's nothing we can do to simplify it. That's it. The topic is properties of real numbers and algebraic expressions. The first objective in this topic is use operation and order symbols to write mathematical sentences. So let's start by talking about algebraic equations. An algebraic equation is a statement that two expressions have equal value. So when we have equal, that's an equation. Equality is noted by the phrases equals, gives, is, was, or should be, yields, amounts to, represents, is the same as. So when we see these key words, we represent it with the equal sign. Otherwise, it's just building an expression on the left side of the equal sign and building an expression on the right side of the equal sign. So let's write each sentence as an equation. The difference of 7 and a number is equal to 42. So there's our key equal phrase, is equal to. That would be the equal sign. On the right of the equal sign, we just have the number 42. And on the left, we'll have the expression for the difference of 7 and a number. Order matters when we are talking about differences. That's subtraction. The difference of this and that. 7 minus, and we'll use x for a number. 7 minus x equals 42. B, the quotient of y and twice x is the same as the product of 4 and z. So is the same as, there's our equal sign. To the left of the equals, we'll have the quotient of y and twice x. To the right of the equals, we'll have the product of 4 and z. Quotient means divide. Quotient of this and this. Y divided by twice x. Twice x means 2 times x, that's 2x. Y divided by 2x is equal to the product of 4 and z, 4 times z, or 4z.